Hello, everyone. My name is David Paulson. I am an escalation engineer with Microsoft. I've been supporting Exchange now for almost 10 years and been doing an escalation role for probably about 4 or 5 years now. Um, Today, we're going to be talking about a little bit with troubleshooting Exchange servers performance issues, but mostly the importance of collecting the data that is required to review the logs because we're not able to really review customers' data live, and there's not an easy way to review live environments to show actual performance issues. Um, so let's go ahead and get started. What is needed to troubleshoot performance issues? If anyone wants to go ahead and type out in chat or come off mute and say what they think is required, please go ahead here. Give you a few seconds, maybe even to think about it, have some answer in your head. Well, can't quite can't quite hear that person. So the thing that you need is actually performance data. Many times I've seen throughout the years is customers and engineers will try to troubleshoot a performance issue without ever collecting performance data for weeks, or they go through and collect performance data once and just assume that that's always the same set of symptoms, same issue that's occurring without ever collecting it again. You cannot troubleshoot a performance issue without actual performance data. It's just you're not going to be able to successfully determine the cause and assist with determining what's going on within the environment that is leading you to have those types of issues. So what are the different types of data that you need to collect for these types of issues? Um, the biggest one is performance data, and that is there's different types of ways to collect this. One being simple perf, experf was, and daily performance logs. Um, simple perf is basically a script that replaced experfwiz that is simpler to use, and it's able to run across multiple servers and collect performance data collection. It goes through, runs, and it's able to run on different OS servers for English and non-English. And this is a huge win for us because people over in Germany are now able to run this, whereas experfwiz, the script that we used before, was never able to translate the counters that we needed. And you're able to collect it at a lower interval, unlike daily performance logs, and have additional counters be added to it on the fly. By default, it just also has more counters than what is within the daily performance logs as well. Daily performance logs, in most cases, is a good start to collect, but it's usually not enough data to actually troubleshoot performance issues. For example, if you're running into a database failover issue caused by Hunt.io, you're not going to be able to determine the cause of that because Hunt.io is determined by 10 seconds. By default, daily performance logs is collected at a 1 minute interval. You are going to miss the cause of that issue every single time. And that's why one of the reasons why simple perf is needed to be collected. The next type of data that's extremely useful to have is what's called Windows Performance Recorder, or WPR. This helps significantly when you're troubleshooting a high CPU for a single process because it's able to provide the stack information down to the percentage of where we're actually spending our time at within the stacks. It's also great for troubleshooting disk I/O issues. You can actually see which process is sending all the IOs down to it, and then along with that, the stacks of those processes. And it's also able to help troubleshoot with high memory consumption where a process is just not releasing the memory. It records the stack that is requesting to allocate the memory and then never releasing it. Another common thing to go ahead and collect is store port traces when you're running into a disk I/O issue. How many people have ran into a disk latency issue went to the storage vendor or the storage team on the customer's end and said that there's no storage issue, even though the counter clearly says that there's a storage issue. Well, a lot of times what ends up happening is they just go check the disks themselves, look at the logs, oh, no errors, or look at the latency at that time, and there isn't a latency issue occurring anymore, and they say, oh, the disk looks fine, nothing's the matter, everything looks good, it's not our issue. Well, the problem is they not only own the disks themselves, they also own the entire subsystem to the disk. Windows can only go so far, and the last point of data collection and place that we can actually assist with troubleshooting or determining any type of latency on our end from the Microsoft side is with store port tracing. And that's the lowest layer that those IOs are actually leaving the OS. And we can collect those store port traces, and you need to collect them during the time of the issue. Otherwise, if you collect them when the issue isn't occurring, obviously you're going to see everything's just fine, and then potentially get down the wrong track of assuming that the latency is higher in the stack at the potentially third-party filter drivers or AV or something like along those lines of troubleshooting, because you already ruled out that the store port tracing shows no latency either, but your discounter's dead. That's also why you need to collect those information in tandem to get a better overall view of what's going on. Proc dump is often a lot of times what we see get collected, and it's actually the worst way to go about troubleshooting a performance issue. A lot of people get it in their heads that proc dumps or taking a process dump is going to be the end all cure all. Like, we know exactly what's going on. But a proc dump in itself is just a snapshot in time of a user mode of the process. And it doesn't give you the full picture of what's going on. When you're troubleshooting a performance issue, you need to understand the entirety of the server and what's going on with that process. Why are we doing all these requests? Is the issue even occurring inside a user mode? Those are the things that we need to answer before we just jump into getting a proc dump. So, and proc dump of itself, when it collects this information, it freezes the process to collect the dump, and that can take anywhere from a few seconds to a couple minutes. And while it's frozen, it can't process any requests. So when it comes unfrozen and is able to run again, it has to try to process all that stuff again, and then adds more load to the server. And if it's a process that's client connectivity wise, like W3WP for MAPI app pool, if it takes too long, the request can actually time out for what Outlook is sending to the MAPI app pool, and then request it again and again. So then you have multiple requests potentially coming to the server yet again, while it's also trying to finish boarding or processing the current request that was frozen in time when the proc dump was collected. Realistically, proc dumps should only be collected when an escalation engineer like myself, who is able to review the dumps, is requesting them. There are some scenarios where proc dump is beneficial to collect, but it's not the first step that we should be taking. First step is always going to be regular performance data. The next step is going to typically be WPR data before we ever jump into just collecting proc dump. For example, I recently had a case where a customer decided to go through and collect MS-Exchange REPL because it was the highest process consuming the CPU. It was consuming like 60% of the CPU. MS-Exchange REPL typically shouldn't be that high, and they just assumed that taking a dump would give them the answer. Well, that wasn't the case. They collected a single dump without any performance data to correlate with what's going on with the server, and they just assumed that taking a dump of that process would give them the answer. Ended up reviewing the dump. Everything looked okay. It's just shipping logs. Everything looked normal. Because it was a single dump and no correlation data, there wasn't anything that was fruitful from the dump. We had to go back and actually collect actual performance data to understand that, oh, hey, the reason why we didn't see anything within the dump was because Of that 60% of the total CPU that was being spent inside of MS Exchange REPL, 59% of it was spent in privilege time, which is kernel mode, which you're never going to see in a proc dump. Because again, proc dump is only user mode based, where kernel is in the system. And we're never going to see what is those threads or that part of the stack inside of a user mode dump. So that's why you never want to just go through and jump into taking a proc dump. So why is performance data required? It gives you the entire view of the server's performance. So if you're looking at a server that has high CPU, you open up Task Manager and see that, oh, hey, MS Exchange REPL is causing high CPU. You don't yet understand that underneath the hood, that it was all within privilege time. And therefore, you don't know which steps to take next. That's one of the reasons why performance data is extremely useful. Another reason performance data is extremely useful is because you can only look at one or two things typically live on a server. And there could be multiple reasons why high CPU issue could occur because of disk, locks and contention, privilege, processor bottleneck for various number of reasons, networking issues, and you just can't look at all those things before maybe the issue stops occurring, because you get a monitoring from clients saying, hey, I can't connect to my mailbox anymore, and then multiple people are reporting it. All of a sudden you go look at the server, it lasts for another 5 minutes, and then everything's okay. So you can't troubleshoot an issue like that live. It's always best to, as soon as you get on the server, start performance captures, and then start to look at issues live. And then you might be able to figure out where it's going on. If not, you have that data to go back and refer to understand what was happening. And then you also always will have the daily performance logs, providing that the daily performance data collector set is turned on and enabled, and you didn't have it disabled or turned off for various reasons. So, like I said, you can have this things occurring like disk I/O latency, and some of those things you just don't think to look at when looking at the server live. Another great example for why you should be collecting performance data is it gives you a historical data point to compare against. A lot of times we'll see one issue come up and clients can't connect, and it's because of high CPU. The next time it was because of networking. Those still cause the same issue as client can't connect or client latency, but completely different causes. So it gives you a point to actually say, yes, we're troubleshooting the same thing still over and over and over again, versus same set of symptoms, different causes. And it also gives you a data point to compare against between a couple different servers to let us know that, hey, this issue is actually occurring across multiple servers at the same time, or if it's cascading to another server. A server goes down, network load balancer fails over that server to a single server or subset of servers, and then tips that server over, then it causes cascade effect. That's why we need to have the performance data. And again, to compare against other servers for this reason. Yep. There. Okay. And then also, what started first? If you, by the time you get on a server for the first time that you are experiencing an issue and noticing that you're having high CPU, sometimes you're able to determine the cause right away because you have high disk latency. That's typically never going to change. High CPU, most, I would say like 99% of the time, is going to be caused by disk latency versus high CPU causes disk latency. Not that every single time a high CPU issue occurs, it's caused by disk latency. What I'm saying is that you typically never see it in reverse, where high CPU causes disk latency, unlike some other symptoms that you can see, which high CPU will cause those things to occur. A good example of what came first is if you have an issue that's experienced on all of your servers at the same time. Typically, that's caused by either a mailstorm of some type, whether it be a single large message or something along those lines, getting sent to the environment. And when we do that, we're trying to deliver that message basically at the same time, which can cause high CPU. Another factor that can occur is networking, something on the network. Other than that, there is typically nothing in Exchange that would cause all the servers in your environment to experience the issue at the same exact time. What you can actually see more often is that a server goes down and then you see a cascading effect, and that will appear as all the servers are having the same type of issues. So it's just important to know what is actually coming first and having that type of data. When should you be collecting the performance data? When you are experiencing or suspect you are experiencing a performance issue. You should always be collecting the data with simple perf every single time. Simple perf should almost always be running in circular mode or some fashion, so that way you can get the data leading up to that point, to get that critical first, what happened first type issue, unless told differently. You should always have that running. And you should always have it being collected, even if we need to collect WPR or if it's asked to get that information. Because with WPR, it's hard to tell exactly what time that the information was collected. This gives us the number of seconds that it was collected. So with regular performance data, we're able to see that process start and when it stopped. Therefore, we know the exact time of time of day on the server when that data was collected. So it gives you a better overall view of what's going on. Same thing with store port trace. You want to be collecting regular performance data when store port's occurring, because again, a lot of times we say that, hey, we need a store port trace, or hey, we need to collect information from the storage team to say we're running into an issue. By the time they can get involved or recollect that data, there's no longer an issue occurring. So it's a way to help confirm that, yes, when this data was collected, we were in fact seeing an issue, or no, we were not seeing an issue. Therefore, this data is not valid. And also the performance data helps confirm the issue that you're seeing every single time, and the exact time the issue started to occur. Because sometimes it takes clients to, 10 minutes or so to report in an issue. By the time the admins are aware of it, we could be looking at a completely different time frame than what we should be. Another reason to collect performance data is to rule out a performance issue. You can have slow client responses coming from the Exchange server, or at least that's what it appears to be, when it could actually be a networking issue or an individual mailbox just being so large that it takes that long to do some requests. So that's why we need to collect performance data from the server, just to rule out that we're not contributing any factors of our server's performance to the additional latency of the clients. An example would be also if you're experiencing slow client responses, is like if you're dropping packets on the server. We can see that within the performance data rather easily. Another thing is intermittent issues. When you think of intermittent issues, you should always be thinking to collect performance data because we can see exactly what's going on with the server and the entire environment if you collect it on all the servers. We can see that at 8 a.m., all your users are coming into the office, signing on, and we can see the requests start to ramp up, and then all of a sudden we hit a certain threshold and it drops down. We can see that exactly, and then we can look at the overall performance of the server at that time. Is there a reason why we dropped the connections, or is it likely something to do with networking? These are all things that can be easily answered with performance data versus just regular logs. And with performance data, you can actually have a visual view at the time of day that everything is occurring. Another time frame when you should be collecting performance data is a baseline during production hours. It is a good and highly recommended practice that I've been trying to teach people to do. They never seem to understand the reasoning for this because there isn't an issue occurring. Why do we need to collect performance data? You know, but it gives you a baseline to understand where that server should be performing at for that individual environment. Because a lot of times counters have certain thresholds that we can definitely easily define. Others is dependent upon the environment, like the number of connections coming into the server. One day it could be 2,000 connections coming into this one server, and then the next day it's 10,000. Why? Is it because of the network load balancer, or is it because of a holiday? What were those reasons, and why didn't we see this before? Sometimes you can see those CPU, you're having a CPU bottleneck even before an actual user is complaining. Or disk issues, or you're just consistently dropping NICs throughout the day, and that's why when a burst of activity comes in, your NICs just can't keep up, and that's when the users start to complain. So we can actually see if you have a bad performing server, even outside of those bursty type of activities. For example, like one of my first cases as a Microsoft employee was a performance type case where we were seeing high disk latency issues, and they had AV constantly scanning the drives. Clients couldn't connect, they're very laggy, those type of symptoms that were occurring. Provided just to disable AV because AV was doing active scanning on the server. After they disabled AV, everything started working. So this resolved their issue that they were seeing. However, we went through and collected another performance collection and saw that their disk latency was still way above the threshold. And the only reason why disabling AV helped was because it wasn't at like 80 or 90 milliseconds for an average anymore. It was more like 25. So we were able to respond to the user request in a reasonable amount of time where they weren't seeing as much of an issue. So the overall resolution for that was the storage issue, not actually AV causing the problem. They just added more load, and we took away that additional load to the disk so that they would be able to respond a little bit quicker. And it's also to understand what the server is doing overall. So there's multiple counters on the Exchange server that provides insight to what each component is doing. For example, I will collect performance data when I'm troubleshooting a database failover issue, even though it doesn't look like a performance issue, because with that, I'm able to correlate exactly when the database failed over besides just the event logs, and then understand how the server is responding overall health-wise. Because you could be running into an issue for the database failing over because we lost quorum, or this node is deemed to be down because of a networking issue. Well, there's also additional counters, like I said before, where we can actually see packets being dropped completely. And that's why performance data is being collected for those types of scenarios to get an understanding of the overall health of the server is extremely important and very valuable for these types of cases. When should you start the data collection? Performance data should start collection prior to the issue. You can do this various number of ways, depending upon what you're troubleshooting. If it's very infrequent when the issue occurs, you can set up in like a circular mode fashion and just have it always running, so that way you don't have to worry about it. You can have a task running to start it at a certain point in the morning prior to end users coming online, but it should be collected prior to the issue. And the reason why we want it prior to the issue goes back to understanding what is happening first, because you can have so many side symptoms because of that first causality. With WPR, you typically want to collect it during the issue for 90 seconds with a concurrent simple perf or some type of performance data being collected. The reason for that is to understand exactly when that WPR was started, when it stopped, and what was the overall health of that server. Otherwise, with not just the CPU counters, but how many requests were actually coming into the server, how many transaction logs were regenerating, if it's like an issue with MS Exchange REPL, those types of things. You can sometimes collect a WPR when we're not experiencing the issue. Dependent on what the issue is, might be able to help. For example, if you're having an issue with privilege time, it is possible that you will see, even when the CPU is low, the reason why you're spending so much time in privilege, because those third-party add-ins or other system files are always going to be executing on a normal basis, and you can actually see what is using up that most of that. And also, if it doesn't give you the answer, it'll give you a good baseline in comparison for when the issue does occur. Store port during the issue. You need to collect the store port obviously during the issue, because otherwise you won't be able to determine that, yes, there is a latency issue. When we were seeing the issue with the logical discounters having a high average latency above 20 milliseconds at a higher level in the stack, because otherwise the store port is kind of not of as much value, because when the issue isn't occurring, obviously the store port is going to confirm that. And the whole reason to collect the store port is just to confirm that the issue is beyond the Windows driver and is on the storage team to then take the reins of the issue and troubleshoot and figure out where that issue is occurring at. Proc dump is only when it's requested by an EE or someone that's going to be able to review the information. Again, concurrent with simple perf. The only reason why someone might want to request this is to actually look at what's in memory. If we are processing a very large list, how many items are in that list that's causing this type of high CPU? What are certain objects set to? Those type of things. But most of the time with code review and then WPR, we would be able to determine a lot of this stuff without ever needing to collect a proc dump. What servers should we be collecting from? I'd actually like to see if anybody knows which servers we should be collecting from. If you can type out an answer or come off mute. Kind of gave away the answer a little bit here earlier in the call. Exchange plus DCs, that's good. Typically, you'd only need to collect it from the DC actually when you're running into an issue specifically with LDAP latency, and you know it's no LDAP latency. All of them. I love that answer, because that's exactly what I would like to see every single time if we can. Granted, with some customers that have hundreds and hundreds of servers, it's not always possible, and it's not always happening on all of them. But we would like to see on all the servers in that region or that we're connecting to, if possible. Granted, some of the times it's 100 servers. No one's going to want to go through all those servers. I mean, I don't want to go through all those servers, but the concept is that we should be collecting from them, because then you'd be able to see how every server is responding, and is all the servers actually reporting the same thing. So realistically, multiple servers, all if possible. Just really depends upon the environment that you're running in or looking at. But 2 to 4 servers is like the minimum, like that we should be collecting from, that are experiencing the issue. And you should also be collecting a couple more from the servers that aren't experiencing the issue, if that's possible. That would be in the same server load, same server pool, like if they're behind the front end, the network load balancer. So that way you can help compare, why did server A run into the issue and why is server B not? It's better at times to get this information than baseline data, because you can actually then compare apples to apples right then and there. An example of why you should be collecting from multiple servers is because you have a better understanding of the environment and actually can see that server A went down the exact same time as server B, with the front end connections dropping significantly down. So that to me would tell me that something on the network or the network load balancer, for whatever reason, marked it down. If we don't find another reason why on the performance data or any type of logging as to determine why we would be running into an issue, and like if we can see all that information in like the health checks, there should be no reason why we got marked down. Therefore, it's likely something on the network, whether it be the NLB or an actual network switch or something like that, that dropped all those connections at the exact same time. Another example would be if one server went down 30 seconds prior to this other server, and that server went down, and then all of a sudden you can see all the connections that were on server A went over to server B and wasn't evenly distributed. That is why that server went down, and it just causes cascade effect. That could typically be an issue with your network load balancer failing over all the connections to a single server versus evenly distributed them throughout the pool. And if you only collected the data from a single server, you never be able to determine if it was something on the network. It could have just been something on the server went down, and we will never be able to definitively determine that your entire environment went down at the exact same time. It might have just looked that way to an admin because all the users were complaining. Yep. So, and then as I said before, include servers with similar load and no issue is the ideal situation there. Heard someone came off mute. Did you have a question? No? Okay. Things that we should be looking at inside of the performance data every single time. I usually just jump into high CPU. Are we having 90 plus total CPU utilization occurring? This is usually where I start off with when I hear client connectivity or anything, regardless if customers complain about CPU utilization, because I want to know if the CPU is acting normal. And if it is high, what is causing that highness? Is it a single process consuming 60 to 70% of the CPU for an extended period of time? Key point being extended period of time, because you can see spikes on a process, and that doesn't make have it to be a problem. The overall process or the overall server is just high. You can't pinpoint a single process causing it. Then you need to determine what's causing that. Is the CPU bottleneck? Is it caused by burst of activity, high privilege time, disk IO latency, or is it AD latency? And that's a thing that you need to be careful of, because high CPU will cause AD latency counter, or will cause the counters to show that there is AD latency, but it does not mean that AD latency is causing the high CPU. However, AD latency can cause high CPU. So that's why you need to understand what is causing first, or what is happening first. But most of the time, 80 latency that you see in the performance data is being caused by the high CPU on the server because of the way the counter is at in code. It needs to crawl all the way back up that stack inside the user mode, inside of Exchange, to stop the counter, essentially. High privilege time will cause high CPU. If you're spending over 30% of your CPU in privilege time, like say I just recently had a case where it was 80% of the CPU time was being spent inside of privilege. That leaves only 20% left for Exchange. Exchange isn't going to function on that. So you need to understand if that's where our time is being spent. All the processor core is being visible. There's been a feature that's out on some hardware where it will cluster your processor sockets to be viewed as one from the OS. And that is a big problem for the OS because it can't properly determine core counts and determine if we need to throttle processes and certain other things, and just overall causes a problem with Exchange. Processor queue length. If the processor queue length is the number of ready threads basically waiting on the CPU to be picked up and then start executing. Locked contention is where we are trying to lock an object on a thread A, but it's already being owned by a different thread, and therefore you have this contention issue. And if you have a lot of that going on, that causes high CPU because you'll have these a lot of threads just waking up and then trying to access that, and that is very CPU intensive when you have a lot of threads trying to do that all at the same time. And obviously disk I/O latency is another big common one that we see a lot of. Can you have a CPU bottleneck without having high CPU? And the answer is yes. You can actually have a CPU bottleneck without having a high CPU. And the reason you can have that is because of the processor queue length. System processor queue length is basically the number of threads that are ready, but your CPU hasn't picked it up yet. If we're averaging above 2, that is typically something that you need to be looking into. Why are we averaging that high? Because that is the number of threads that are waiting, and we constantly have 2 waiting to be executed. You can see spikes and everything, but if you're averaging above 2 in a normal business day, that makes it easier for your server to tip over. And this is like how it kind of works. Once you're in the ready queue, we're waiting on that scheduler to come through, pick it up, and then place onto an actual CPU core to execute. And then it's just this vicious cycle. So if you have a higher number of ready threads, and all of a sudden you have a burst of activity, that number will exponentially grow, and therefore your CPU will just be super high because your queue is averaging at like 80 to 100, and it always has something to go through and pick up right away versus grabbing the idle process and executing. Can somebody hear me? Everybody hear me? Okay, so someone's just having an issue. Okay.
Yes.
All right. So performance monitor analysis. You need to be looking at multiple servers to see if we're actually seeing the same thing on multiple servers, or even potentially multiple times, because you might be seeing one thing one day and another thing the next day. So that's one of the reasons why you should be collecting the data from multiple servers multiple times. And things that you should be looking at are the min-max average duration view. And because if you're experiencing an issue that only lasts like 10 minutes, 30 minutes, and you're looking at performance data that's the entire day, that isn't going to give you the correct average for thresholds. You need to zoom into the time frame of when that issue is actually occurring. Otherwise, you don't know if that's actually a valid condition that we're experiencing an issue. So you can have like disk latency counter show you an average of 10 milliseconds throughout the day, but you can actually see inside the graph that we kind of spike up a little bit for 10 minutes. Zoom into that threshold or the time frame, and then we're at 40 milliseconds for an average threshold. That is bad. That is something that we would need to address. So that's why you need to be keeping an eye on those things. And also your scale factor, especially if you're using clicking on all the counters and then doing scale. And then you need to understand and know what the recommended threshold values are for some of those counters that do have that defined value, or know what it should be at for your environment. I'm currently working on releasing a blog post actually for this kind of this information on the Exchange Team blog, and also this will include the recommended threshold values for things like privilege time, process queue length, and some of those things, because we just don't have good documentation yet around that. So, and kind of here's what I was going over with the entire view. You have a 50-minute view of performance data, and we were experiencing issues with I believe it was MAPI front-end app pool, where clients were just freezing, not working correctly. But you can kind of see that towards the end, the line kind of balances out and is pretty low. What this counter should be at for an average should be at 10 or lower. And I'm not sure if you can quite see it on this, but it's showing it like, I believe, 8 or something during this view. But if we zoomed in to that smaller time frame where it was higher and removed the aftermath of when everything started to cool down, we could actually see that for 15 minutes we were averaging 18, which is well above our threshold of 10. And garbage collection, for those of you who don't know, is basically the process of freezing the process to clean up memory inside of the process to make room for other allocations to occur, or move it from Gen 1 to Gen 2 address space. Here's an example of where we want to, or the reason why we want to be collecting performance data from multiple servers. These are all different servers where we can actually see the front-end connections for MAPI, and we can see that they basically all dive down at the same time. And we needed to understand why that was occurring. And because they were all going down at pretty much the same time, this isn't the greatest picture, but it kind of shows the reasoning why we would want to be collecting the data from all the servers, because you can actually see that occurring. If it was just a single server or anything like that, what you should see occur is the connections would drop down, but then on other servers, the connections should go up. And that never happens in this view. So we needed to understand why that was occurring. And for this issue, it was actually because of the MAPI front-end app pool had like a weird locks contention bug that we ended up fixing a few years ago. Here's an example of all the processor core counts where we can actually see when it's clustered, there is a problem with us properly utilizing the two underlying CPU sockets. When the hardware clusters, the OS is only able to see half the core count. So if you have two processor sockets, 10 cores each, you would have 20 total cores, but you can only see 10. With the processor information counter, you can actually see the utilization of each socket still. And this issue, you can actually see that we ended up utilizing 100% of the one socket while the other one dropped completely down. This is bad, and that's one of the things that we've consistently run into with that feature in the hardware, and that's why we do not support that, because we just don't test that out, that feature from the Exchange side. And the other thing is, because of the way that we have logic built in within .NET, it doesn't see all those counters or cores there. So when we are trying to determine the overall CPU utilization of a process to determine if we need to throttle it or not, it miscalculates that information. So Windows Performance Recorder and Analyzer, great for identifying high CPU stacks. Privilege time, because it's actually able to view the kernel and actually be able to tell you exactly where all that time is being spent there, unlike ProcDump, and we'll even able to tell you the stack information inside that. able to collect information about memory growth. It'll provide the CPU, the stacks for the memory allocations, and that where the memory was never released. Disk I/O latency, it also, like I said before, it will collect that information, tell you what process, what stack is actually doing those IOs. Here's an example of what a WPR looks like when you're reviewing it. This was a case where we had WPR, or we had collected a WPR where the issue was with WMI se.exe, where it was just consuming all the CPU and all the time was actually being spent in privilege. Kept on, as you can see in that image, that I think it's 25% of that of this view, of this entire view, was being spent inside of the kernel inside of this process. So of the entire view of all the seconds, 25% was inside this single stack there, which is an awful lot. We ended up having to get a different team involved to determine that it was SCCM doing some advanced counter collection. Here's another example with privilege time being caused by a third party. We can see that this overall total view, we are utilizing 8.11% of the MS Exchange delivery within this collection view. And if we drill down some more, we can actually then see that inside the stack information, all this was being spent inside of the filter driver. And I just removed this stack information to show the individual third-party agent because I didn't want to show that. And it's spending 1.8 or 1.5% of our time in that deal, which ends up equaling 18.5% of the time spent in this single stack for that individual process. So 18.5%, which is extremely high for privilege. And then you're able to even dig deeper and then show the total usage within the individual process by removing all the stack information, throwing the module up first. And you can see that we have 6.49% being utilized there, and 6.49 divided by 8.1 ends up equaling 80% of the time being spent inside of this individual system driver, which ended up being the cause of their overall issue. And then you can even see what their overall usage is on the entire server inside that module by even removing the processes there. So that's one of the great reasons why I love WPR data, because it can show you all that information and it's really easy to see what's going on. So anybody have any questions? I know I didn't leave a whole lot of time there and I had a lot of information to kind of go over. Yes. When to use SimplePerf versus XPerf OS? It's really just a user preference. SimplePerf is what I recommend going forward. Biggest reason is, especially for engineers, because it will be able to be run on any OS. Hasn't had as many issues as what the new EXPerfWiz module thing ended up being. All right. Looks like we have a hand up if you want to come off mute.
You mentioned in one of your charts about an issue with the MAPI garbage collection. Do you happen to remember what the outcome was? What did you do to solve?
So that was an issue a while ago. I believe it was the known issue with .NET framework, actually, way back in the day when Exchange 13 was first coming out, and we had a lot of issues, and ended up recommending that, hey, we have to be on this version of .NET because of all the performance issues. Unfortunately, Exchange just kind of discovered quite a bit of performance problems with .NET when 2013 first came out. It really depends upon for troubleshooting back pressure with version buckets. Actually, version buckets are only caused by a couple different things. One of them is, hold on. Buckets. So version buckets are typically caused. Highest reason by is by LDAP latency. The other is disk, and then also with large messages. Very large messages will cause version buckets. So you just need to keep an eye out for all that. A lot of things that we've been seeing lately, I think, has been actually the large messages if the receive connectors aren't set up correctly. Yeah, so like there's a article out there regarding how did this 80 gig message get into my environment, and it's because receive connector was set up to fully trust that sender, and so it skips some of the evaluations with like what is the max limit that we should be accepting from this. Baseline data I cannot, in normal operations I cannot, because some of those things are really dependent upon your environment. For example, like the number of connections coming into your environment would entirely depend upon how big of servers you have, how many users you actually have, and those type of things. I can only recommend what we have for a hard set threshold, and that's really it. But that information is actually coming out. I have something kind of out there that was on the old blog, but it's currently archived out. And it's really hard to find, which is why I'm trying to revamp it and get it posted on the Exchange Team blog. So, and a lot of this information that I covered here today is actually with like the multiple servers, what information to collect, the performance counter thresholds, all of that is going to be within that blog post I'm hoping to get out soon. So, all right, if nobody else has any questions, then we'll go ahead and call it here. Thank you all for attending, and hopefully you enjoyed MEC.